First, we will buffer something. Hi, good evening, all. So, today we are going to discuss a very hot topic within the manufacturing industry. Uh, it's 5G, a catalyst to digital twin technology in manufacturing industry. So, let's start our topic discussion today. So, as you see, we are going to talk about the 5G impact on manufacturing industry, and we are going to cover two important concepts in the entire journey, the digital twin and 5G. So, just to start the discussion today, let me set the context. In the entire discussion today, I will be talking about few important and major scenarios within manufacturing industry which are very much relevant to the profit and cost and optimization and growth of the manufacturing industry, and which is getting impacted by 5G. And digital twin is one of the enablers to enable the those scenarios within manufacturing industry. So let's go in detail. Before we get into the topic, a brief background about my profile. So I'm currently working with Capgemini as a digital director architecture. I have 20 plus years of IT experience, having worked in various technologies and domains. Currently, I'm an enterprise architect at Capgemini, delivering architecture solutions for my clients on application architecture, cloud infrastructure, as well as architecture consultancy. So that was brief about my profile. Now let's start the discussion of the today. Let's take an example of a manufacturing enterprise. Today's manufacturing enterprise, as you can see, has many departments. You have factory across different geographical locations supported by departments like enterprise resource and planning and finance department, customer relationship management, engineering systems, management and planning department, retailers, supply chain and logistic warehouse. These are some of the core departments in the entire manufacturing ecosystem. Now, I wanted to start talking about some of the scenarios, or rather to call use cases, that are very critical to the manufacturing industry, and how the current setup of enterprise, manufacturing enterprise, is facing issues in those areas, and how a digital twin and 5G technologies can help to solve those issues. So let's get into issues first. If you see today, the communication or the information flow between department to department, most likely it is point to point. So I am not generalizing, mm, but majority of the industry, the information flow is point to point and not centralized. We'll come to the details why it is important to have a centralized information flow. Today, not all the systems are connected due to lack of reliable communication network. If you look at the supply chain and logistics, if it is required to track the logistics in real time using a 3G or a 4G or LTE network, you might have observed that these networks are very unreliable, right? So, which means that tracking something which is real time is is really very much unpredictable. Also, take an example of the in the ecosystem. If something breaks down at the factory, then it is very difficult to troubleshoot the machine remotely. Some engineer has to really approach the factory and manually intervene and fix the issues. And also, we have less visibility on impacts if a system fail on rest of the departments or functions of a manufacturing ecosystem. Also, there is a lack of visibility of factory operations in real time. and lack of visibility of product quality as it is being manufactured. So the reason I brought up these points today in the start of my session is because as we subsequently move towards the end of today's topic, we will see how these scenarios will be uh, will become a boon to manufacturing industry supported by 5G and digital twin. So keep in mind the troubleshooting remotely, the visibility of the factory operations, and the quality monitoring in real time. Let's move to the next slide. So, what is the solution? Today, the Industry 4.0, as defined by the group of companies, recommends that the systems should be digital. There has to be a transformation of the systems into a digital. And what are the big asks from such a system? The systems should be made cyber physical systems. That means any as physical assets which is communicating to the network is a cyber physical system, and there are sensors attached to it. Then it recommends everything connected to everything, which is nothing but an enhanced version of Internet of Things, where people, processes, systems, softwares, everything is connected to everything so that the data is centralized and contextualized. Then we can control the systems remotely, whether it is factory operations or machines. And finally, the autonomous operations, which is a goal or a vision supported and very much enabled by 5G today. We will dwell into the details in each of these in the subsequent slides. So this translates into some of the important scenarios that becomes the core of today's discussion. So we're talking about 5 scenarios or use cases. Some of them are relevant to the digital twin, and we'll definitely understand what digital twin is in next few slides. And some are very much relevant directly to the 5G technology. So let's look at each of these scenarios. So when we have a system which is end-to-end connected, enabled by a high-speed network, end-to-end visibility of all factory operations in real time is possible. To be able to troubleshoot machine failures remotely through an application in real time is possible. To be able to monitor product or predict product quality in real time is also possible. We will see how. To let the machines talk to each other and coordinate to achieve autonomy in production processes is very much achievable, and it's happening these days. 5G is just a boost to it. To be able to predict machine failures remotely visible on an application. So we'll look at in detail each of these scenarios in subsequent slides. So as Industry 4.0 suggested, we have the enterprise, all the departments and factory, and they are now upgraded with sensors and connectivity, which means that they have become cyber physical systems connected to rest of the systems in the ecosystem. Systems are connected to each other through centralized software using Wi-Fi, 4G, 3G, etc. There's a big time usage of IoT, cloud, big data technologies while creating the solution. And with this, we feel that we have achieved major end-to-end visibility. The 5 use cases we just thought we have solved with this Industry 4.0 recommendation. So did we really achieve what we intended for? Where is the real-time? So just park this 4 questions for now here and look at digital twin to see how it can solve our remote scenarios. So what is a digital twin? A digital twin refers to a digital replica of physical assets, processes, people, places, systems, and devices that shows visually the subject's current and future state derived from its own data combined with real world. So what you see is a twin of a industrial pump. You see the physical pump, and then there is a virtual 3D model which is showing the details and parameters and characteristics, both operational and physical, in real time. As the piston, as the movement is happening in the physical pump, the same motion is replicated in real time with a similar speed, so that it appears to the viewer that that the person is looking at the real device, even though it is on a mobile application or a web-based application. The technology that undergoes, of course, there are chunk of technologies that undergoes to create a digital twin, but the enablers today are the augmented reality, AR, virtual reality, mixed reality, and 3D enabled software applications for visual purpose. But there are underlying technologies that we will look at later. And as we discussed earlier, the digital twin use cases are suited for end-to-end visibility of all factory operations, to be able to troubleshoot machine failure remotely, and 3D representation of the physical asset with its physical and operational parameters. Twin provides a view on the physical condition of the asset and can predict failure when integrated with machine learning. A process twin can provide real-time machine-to-machine coordination view. So we'll look at different types of twin now. What is a process twin? So if you would have understood the concept of a twin is a virtual representation in 3D format of a physical thing, or or process, or a people, or a system. Now, in order to look at, so if you know today's manufacturing industry is driven by processes, and these processes sometimes become very complex. Now, in order to really fix these processes, sometimes you really have to understand, read materials, look at the processes, and see where you can optimize manually. But imagine if you have a twin of that process, where you have the details of each and every sub processes and processes all together. You can really play with that process interactively and see the conveyor belt. A conveyor belt is can have a machine twin, and this twin can be remotely monitored on a continuous basis. A product twin, we just saw a product twin. What a product twin is, it's an end product which is deployed in the field and can always remain connected to the enterprise, and whenever there is a need to troubleshoot the product remotely, it can be enabled. And imagine the customer delight if you are able to fix the product or predict the failure of the product a week advance, and try to fix that remotely. A factory twin, it's a twin of factories of an enterprise, which shows the entire factory in operation, different departments, their operational parameters like factory performance, product employee productivity, efficiency, number of products produced, stuff like that. So why digital twin? So an IDC in November 2017 predicted that by 2020, so which is this year, 30% of G2000 companies will be using data from digital twins of IoT connected products and assets to improve product innovation, success rates, and organizational productivity. That's a prediction. But actually on the ground, why do we need twin? Because there is a huge cost saving. How? Is you can use twin to prototype a product virtually without even creating it. You're saving a lot of costs here. I mean, you are improvising the product on the twin itself before it is being produced, which means that you are saving a lot of cost in product prototype iterations. You save maintenance costs with the help of predictive maintenance. It's an industry term, predictive maintenance, where the system is able to predict the failure, faster time to market by avoiding delays due to prototypes. by enabling lean manufacturing, by optimizing operational and production processes, optimized efficiency by predicting machine failures, higher yield. How? By optimization of production processes. So today you can use process twins to optimize production processes, which means that you have a higher yield. You are saving a lot of cost here. You're optimizing the processes. You can also predict quality of the product by continuously monitoring the operational parameter of the process. What are the technologies? So these are very very high levels. So basically, people, folks who are from software industry, technical industry, they understand what Internet of Things is, what industrial Internet of Things is, and there are a lot of software platforms today that are catering into IoT platforms. So which means it's a combination of Internet of Things platforms, 3D simulation platform, uh, and then mobile application and web-based application platforms. Together, that forms behind the technology of a digital twin. What are the typical use cases of digital twin? So we have bits and pieces. We have talked about some of the important use cases of digital twin, but as a whole, in the industry today, and these are already in use, are some of these important use cases. uh, the virtual product testing. So if you want to test, let's take an example that you're building a product which is made of a metal, and before even starting its production, you have a twin of that product. You have all the physical parameters of the product, you have metallurgy of the products, you have the mechanics, everything built in the twin, and then you run a test on the product and determine the threshold of when it breaks. Let's say it's a screw which you are testing, and you are running the virtual testing of the product, and you can determine what is the threshold of this particular product when it starts breaking. That's something which is really revolutionary. You are saving a lot of cost in terms of employees who are testing these products, in terms of prototypes, and as well as you are coming up with good quality product in the end. Equipment health monitoring. You can have twins of every machine that are there in at the shop floor, which will continuously start predicting its health and monitor and its physical and operational condition in real time. You can have quality management. I'll just rush through. You have process validation. You can have process twin to validate the process, how effective the process is. You can also have virtual commissioning of the factory. You can have use the factory twin to really optimize the real estate of the factory area, where to put what departments, and how convenient and how efficient it is to create the layout using a virtual commissioning of the factory. Predictive maintenance, as we discussed earlier, it's about predicting the failure of a machine in advance. So, yet the digital twin is not there. Why? With so much of importance that we have spoken about the digital twin, it has not yet really got the eye or traction. And the simple reason is that these are real-time scenarios that are dependent on, so whatever major use cases that we have just thought, it's very very um, bandwidth intensive, because you're looking something in real time on the mobile application or web-based application. It needs a network reliability, because today's network, if you talk about 3G or 4G, the network, sometimes the internet goes and comes back, right? It's not reliable. The latency is very high in today's network, and such scenarios need an extremely low latency at the rate of less than nanoseconds. Huge amount of quality of data for processing. Such kind of prediction needs, the failure prediction needs a huge amount of data that needs to be processed, and that to a quality data. which means that for such scenarios, a 3G or 4G or LTE or broadband network today, the fiber optics are less reliable, not enough bandwidth to fulfill real time. Yes, this is little contradictory with broadband fiber optics, because why I included fiber broadband fiber optics is because there are scenarios where you have logistics and trucks and supply chain, the those also needed connectivity, where the fiber optics will not come into picture, but the 3G or 4G networks will come into picture. So these are very unpredictable networks. Hence, so what's missing basically? So how we can bring the digital twin in the way it is today, showing us the advantage, how we can really bring it live, and how the manufacturing industry can still again start talking about twin and its usage. And in today's scenario, in today's situation where we are in lockdown, remote use cases or scenarios makes a lot of sense, right? So what is missing? Are we missing 5G, which can really boost or become a catalyst? So this is about our topic. So 5G, a catalyst to digital twin and a boon to manufacturing industry. So let's talk about 5G. And 5G in itself is a very detailed topic. I will be just covering to the extent uh, as much it is required to prove the topic of the today. So 5G is a wireless technology that offers faster speed, reliable connections, and low latency on connected devices. That's something which 5G is offering. So as you see on your screen, it has some of the core unique features, and they're calling it with abbreviation MMTC, massive machine to machine type communication, which is 5G network is enabling communication between machines. So today, take an example: a fan can talk to a tube light, a conveyor belt can talk to a robot, right? That's the kind of machine to machine communication we are talking about. EMBB, enhanced mobile broadband. So now we are talking about broadband on the wireless network, which is quite amazing. URLLC. So 5G is promising us ultra reliability, which means that you can really trust on the network, that the network will continuously be available for mission critical scenarios and use cases, and very very low latency communication, URLLC. And there is a very unique feature which was also there with LTE. It's called network slicing. It is nothing but 5G is providing you a mechanism where you can have your own private network for the enterprise. And that is really very good, because private network, your own enterprise network will enable you to have a secure network environment for communication across the globe systems. And that means 5G will enable expansion of capabilities of augmented reality, virtual reality, mixed reality, IoT, AI, machine learning, digital twins, and so forth. Which means that it guarantees a high speed internet, which is of the order of 1 to 2 Gbps, ultra reliable, low latency, that are key requirements for a digital twin applications. So if you recall, we have talked about remote use cases that were dependent on high speed, low latency, reliability, and 5G is promising those. So it's a very direct uh, correlation between 5G and digital twin, how digital twin can be leveraged by the manufacturing industry today to solve the most of many of their major problems with optimized cost. And So let's take a look at those use cases or requirements or the scenarios together. How 5G is helping these scenarios. Remote troubleshooting and fixing machines through a connected robots. Now, if you recall remote troubleshooting, if I'm using a robot to fix a machine, I need very high speed, very low latency communication, and that too reliable. It should not get disconnected. And 5G is definitely providing that, which means that in today's scenario, this is absolutely possible. Factory Twin offers real-time view of the factory operations on digital twin applications. So today, if an enterprise has tens of factory global location, and every factory is producing tons of operational data on a daily basis, and to have a, a better performance, a predictable performance of the factory, better quality and huge data is required, and that means you're at a fastest at a fast at a good speed, which means that your EMBB, which is enhanced mobile broadband from 5G, definitely comes into picture, provides that enabler to really move the data fast from one system to another. Again, a digital twin scenario, an application showing machine failure in real time with operational parameters and exact location of the failure, again enabled by those 5G features, high speed broadband and ultra reliability features really comes for rescue. In factory closed loop process level collaboration between machines for automation. So till now we were talking about digital twin and how 5G is enhancing those digital twin scenarios or use cases for a manufacturing industry. But the last two use cases or the scenarios are more directly related to 5G features. One is the machine to machine communication. If you recall, we just spoke about machine to machine communication, where the network is providing enablers where you can where thousands of devices can talk to each other over 5G network. And if you think for a while, let's take an example of a tire manufacturing industry. It has some four or five process, so raw material mixing and then rolling, molding, rolling, pressing. These are the process, sub process in the entire tire manufacturing process. And if every machine which is handling each process, so let's say there is a machine which handles mixing of rubber, there is a machine which handles molding of the rubber raw material into a tire shape, there is a machine which presses the tire, right? Now each of these machines, if they are able to communicate with each other without human intervention through machine to machine communication using 5G network, don't you think it's that amazing? Because then in scenarios like lockdown, you are still making sure that without human intervention the machines are coordinating and the process is going on. Yes, of course, there will be supervisory process required to supervise such an operation, but then with 5G, the machines are capable enough to take actions in a coordinated way and talk to each other. Is something which is definitely enabled by a 5G network. Another important use case, which is other than digital twin and which is also enabled by a 5G network, is real-time quality anomaly detection. Of course, this is a machine learning, artificial intelligence use scenario, but how it is related to 5G is because let's take an example. There is a conveyor belt on which a product which is being manufactured is going from one machine to another. through the conveyor belt, and there is a camera attached on top of the conveyor belt which is taking live pictures of the product in real time. Now what this scenario talks about is, as soon as the picture is taken of the product, the the picture can be processed to find out if there are any manufacturer defects like cracks or unusual colors or some or anything like that. Now imagine if hundreds of products pass through conveyor belt in few seconds, the speed at which the anomaly detection should happen should be enormous, and that automatically derives to our conclusion that 5G, with its enhanced mobile broadband, ultra reliability, low latency features, can definitely enhance or enable such a use case in real time. Of course, this detection has to happen at the shop floor so that if there are any anomalies, the supervisor can take action to stop the process subsequently. Here are some of the list of 5G enabled scenarios for manufacturing industry that I've prepared. So let's quickly run through it. Will not like to go in details for each of these. So I've categorized these into several use case families. What are the time critical scenarios we have just talked about? In factory closed loop process level coordination, which is machine to machine coordination. And if there are any uh, accidents or no danger zone that are there in the shop floor, how quickly a camera or a sensor detect, and then real-time alarms can be sent, right? Those are the time critical use cases for now. The remote interaction use cases that we spoke about is remote troubleshooting and fixing machines through connected robots, remote real-time machine in motion and interaction through our augmented reality and virtual reality, and as well as the 3D AR, VR, augmented reality, mixed reality based remote trainings is also one of the remote interaction use cases. Advanced analytics and prediction capabilities, as we talk about machine failures through digital twin, enhanced computer vision capabilities. We just spoke about the camera example where the anomalies on the product can be detected. Now, the descriptions are provided, and what are the 5G technologies that are supporting these use cases are also part of this list. Now, before we, so I have reached to the to the end of this session, and I wanted to end the session with some technical flavor to it. I understand that there may be people who are students and they are from um, different domain, different subjects, different departments. But I'll try to see that I explain the entire flow in a very layman's term. So just concentrate on how I navigate from bottom to top. So what you see in your top, the red color box is a 5G network, which is where we are using 5G network slicing feature, and it shows that all your machines under this network connected to this network, like your this device, the computer, the PLC, the robots, the conveyor belt, are all communicating through machine to machine, M to M capability of 5G network, because all these machines are connected to 5G network. So they are coordinating to achieve a process. Now, this shop floor devices is continuously broadcasting data to something called as manufacturing hub. People who are from software industry, they understand what big data, what data lake is, and people who do not understand software terminologies. It's nothing but store. If you might have heard about something called as database or a storage mechanism, it is continuously storing trillions and trillions of data from the shop floor in some centralized computer, which we are calling it as manufacturing hub. And then there are artificial intelligence software which are running on top of this data to arrive at predictions. So using this data, you can really derive whether a particular machine like a robot or a conveyor belt, which is going to fail in next 1 week. All all this is done by the intelligence services part of the software platform, which is running these intelligence services, artificial intelligence processes on the data which we have stored on the computer. And this prediction mechanism as a data is provided to the applications like mobile applications and web-based application. We call it as digital twin or web-based application, which actually shows these predictions in the form of application in 3D model, right? So, in a nutshell, this is how the the entire end-to-end uh, software, centralized software looks like when we try to connect everything to everything. So imagine this particular software platform is connected to a shop floor systems and machines and devices and sensors. The same platform is connected to enterprise ERP and CRM systems like SAP and Salesforce. The same system is connected to the supply chain and logistic, the courier service and trucks through the sensor. They're using 5G network to broadcast the data to this same platform. The same network is connected to the retailer which is selling the product, and to the warehouse and to the management department. So that's how this product is able to capture so much of data, and then is able to provide a prediction and enable every other department or operational department's operational area to effectively optimize their operations based on the processing done by this platform. So with that, some of the references that I took while preparing this material, I just have come to an end of this session. So we are now open for question answers. Okay, I'm just going through the question answers. Okay, so Mr. Krishna from Hyderabad says, I think um, most of the industries run with conventional machine. Is it not costly to change over to digital manufacturing? You are absolutely right, Mr. Krishna. But the way entire transformation has to adopt it is in phased wise manner. So today we talk about any service provider company like Capgemini. Uh, the recommendation is to have a gradual transformation, not a big bang transformation. So we adapt to their legacy system, their existing machines. Um, the core machines, that we make them cyber physical systems, attach sensors, and then when they start create bringing value, the rest of the machines in the value chain will be transformed. So it's not big bang, but it's gradual. The next is, uh, the session is very interesting, Naveen, thank you very much. Will you send any certificate, as I have attended all the sessions? So this is not something which I will be able to answer, Naveen. Then Mr. Anthony asks, role of IT management professionals in manufacturing industry 4.0. Oh yes, It's a very good question asked by Anthony from Sivaganga. So I definitely see a big role of IT management, not only IT management, but IT professionals uh, in um, in the manufacturing industry 4.0, because if you have seen the entire presentation, the technology is converging, every industry is converging, and which means that to bring those changes, digitize, make the system cyber physical, definitely IT professionals are required. It's really amazing, learned many new things, good and excellent. Thank you, Dipti. uh, how 5G is more useful in AI and IoT? Excellent. So it's question asked by Mr. Sachin Bisan Rao Charbe. Okay, so as you know, for an artificial intelligence kind of scenario, an artificial intelligence, if you talk about robots, humanoids, where it needs huge processing power in real time, and as well as huge data for processing to be able to answer certain questions. So let's take an example. If you're talking to a robot and you've asked some questions to robot, the robot should be able to answer to you back within few seconds, which means that before even if it answers you, the answer has to be relevant. And how the answer becomes relevant, the robot tries to reach out the internet, tries to access different dictionaries and data present, and then try to correlate and understand your question to be able to answer. And all this needs speed, reliability, and that's how 5G brings a lot of uh, reliability and speed, as well as mobility. So your robot is all the time connected to the network, even if it's moving out or inside or indoors. IoT, definitely. Whatever I just walked through, IoT is the core of everything, right? So definitely IoT is really impacted with 5G. Okay. Mm, so question asked by Vanita. She says, Vanita from Madurai, electromagnetic compatibility in ECE real time example is needed. It will be really useful. Uh, Probably I may really have to understand what ECE is, but yes, if there are some examples that you think are very much uh, relevant, please either put it in the comment or write back to us so that we can connect and see if we can elaborate that. Okay, there's a question from Dr. Jagdish Amlaraj. Why BSNL didn't get 4G? So that is something which government can answer. I can't answer that question. Okay, so there are a lot of wishes coming from Spurti from Kanpur, saying, Sir, I wish Ramzan Mubarak, sir, how I utilize my J2 in Java developer skills career in Catalyst to digital twin technology. Of course, you can definitely utilize your J2 in Java developer experience, but I would recommend that you go and try to enhance your knowledge in IoT, which is more relevant to manufacturing use cases. Okay, so how planning about 5G means what will do the first step? I really didn't get this question, but still see if I can attempt to answer. Sir, how planning about 5G means what will do the first step? I'm sorry, I have to really, I'm struggling to understand this question, Nidhi. Um, Question from Ankit Shankla. Can such type of technologies applied on small scale business rather than big manufacturing industry with cost? Of course, yes. Any type of technology can be applied to small scale and medium scale business. Only thing is that such huge platforms comes with huge cost because the amount of data generated by big corporate is huge. Mostly your cost consumption is only for huge data storage and processing part, right? But yes, if it can also be leveraged by smaller scale industries, we just have to tweak our architecture and system design that in a way that it becomes cost effective for smaller scale industries. Gopika, simply awesome, nothing like that. So thanks for that comment. Um, what is the major difference between the 5G technology? I If I try to understand this question, what is the major difference between the 5G technology? Probably you're asking what is the major difference between 5G and 4G. I I'll try to answer in a way that uh, first is your speed, your enhanced mobile broadband. So 4G and LTE networks do not reach to a broadband network speed. The second one is that the 5G is talking very strongly is machine to machine communication, which is not enabled by 4G or LTE network, which means that the devices today, if there are IoT enabled devices like your, I will take a very domestic example. Uh, Talk about fan, a tube light, a bulb, a refrigerator, a TV. They can talk to each other using a 5G network. That's a kind of device to device communication we're talking about, which the existing network do not provide. Shiju George from Kottayam says that when can we expect full 5G implementation even for small scale industry? So this is the question is out of the context of today's presentation, but it's more on the government to provide or approve 5G network implementation in India. Farhan Ahmed from Kolkata says, "Is there any certificate for this session, please?" I'm not. I cannot answer that question because something which the organizers will be able to answer. Krishna from Hyderabad says, "When the entire plant is one physical location, why do we need to go for wireless 5G when we can cable every machine?" So very good question and good that you were, I think, concentrating on my um, discussion today. So if you look at, if you recall the initial uh, slide, I was talking about factory in the middle and then all the departments across. So you talk about physical office space. Let's say your factory is in Chennai, but your head office is in Delhi. Your engineering department is in Bangalore. Your finance department is in Tamil Nadu, somewhere, Coimbatore. Your and then your warehouses are at different cities in different locations. And if you remember, the 4G industry 4.0 recommends that everything has to be connected to everything, which means that you need a wireless connectivity in order to connect everything to everything. And the reason why do we need to connect everything to everything is very simple. Tomorrow, if I want to find out which product arrived from which location, which plant it was manufactured, which ERP system in which city it was taken as an order, which customer it went to, all the systems should be connected so that the entire postmortem or history of the product can be obtained if the systems are connected together and centralized. Narsima from Gidalur says that excellent. Is it possible to fabricate devices through industry? 4.0. Obviously, today's devices are all cyber physical. I mean, many smart devices are cyber physical devices, and it's definitely possible to fabricate such devices. Um, there's a Avinash Chaudhary says that wonderful lecture, thanks. In this COVID situation, when will you see the rollout of 5G? So that's something which government can answer. I cannot, but I would expect that it will take another couple of months, probably for maybe 6 months, because it's all approval in the approval phase, and we'll see when it is there. I'll There are hundreds of questions. I will have to look at the important ones. So, okay, there's a question from Ishan from Pune says that, sir, we students planning to do BE project on digital twin. It will be helpful if you guide us with the prerequisites we need for developing the product twin. Of course, I can definitely guide you. I'll have to figure out a mean how to guide you. Maybe organizers can provide you my email address for further communication. Uh, how a mechanical engineering graduate can have a career in digital twin? Is it required ML for a mechanical engineering graduate? Believe me, is more in demand these days because of industry revolution. Keep your mechanical engineering graduation degree, uh, complement it with software, IT knowledge or certificates in the area of cloud and IoT, and of course machine learning on AI will be an added advantage for you to see something your career around digital twin. Sanju from Mumbai says that good lecture on 5G. When will it start in India? Probably in another 6 months, something which government can uh, provide more information around that. Needs more lecture. Very beneficial lecture for me. Thanks, sir. Learn my new things. Thanks, Satya Prakash from Punjab. Okay. So I have 10 minutes left. I can still go through some of these questions. Uh, how much cost saving do you observe in terms of what percentage of manufacturing cost? Pragya from Relic USA. So it's a very, it depends on industry to industry, Pragya. But I see almost a 25 to 30% cost saving with this. Of course, it can be more, plus or minus 5%, but I definitely see 20 to 25% cost saving in this. And yeah, Shruti Dave from Pune says that, is it possible to reduce power consumption using 5G in digital twin? So, what power consumption are we talking about? But yes, there are certain projects that we have done not outside of digital twin. Probably it can be converted in twin. Is how to optimize electrical power consumption in industry, and we have done it for very some of the important outlets, the food outlets, fast food outlets in India. Very promising results we've achieved by saving their power. So this is done in combination of artificial intelligence and machine learning, utilizing some sensors to see where the consumption, electrical power consumption is going, and try to optimize and take actions. It was a very good session about 5G. So what will be the impact on small scale industry which are working with traditional machinery? So impact in terms of, see, for a traditional machinery, we call it as a legacy machines. uh, we need to have a way to convert these machines into cyber physical machines, which where it can communicate with the rest of the network, and it is something which is really doable. I mean, it's and very in a very cost effective way. I mean, you have to really attach some sensors bring some boards and connect to the machines, and connect it to through the Ethernet to the network. So it's something which is, and this is asked by Dhanraj Kumawat from Vadodara. How is 5G supportive in Industry 4.0? I think the entire lecture, Arvind, I was talking about is 5G support for Industry 4.0. Maybe you can relook at the entire lecture. So your maybe your question will be answered there. Surendra from Chennai, sir, may I know the application of 5G in rocket and interstellar missions? Very out of scope. My scope. It's a separate discussion, and I will have to do some research around that, frankly speaking. Okay, two, three more questions I will take, and then we'll wind up the session. Santosh from Erode says that whether digital twin can be applied in e-waste management system, and that is, of course, yes, it can be applied. You will have to create a twin of the e-waste management process, and and then you can definitely look at how you can optimize the process through the twin to see that the e-waste management process is really optimized. Whether cyber world can able to provide all the necessary information about the product or its functions. Cyber world, sorry, Santosh, I didn't get this question. Next question is, what is the future aspect of digital twin in technology? As I said, digital twin technology is existing there since last 4 or 5 years, but it did not really, uh, got the traction because of a lot of issues related to reliability, the connectivity, the speed, and the level of 3D simulation required, which is now possible, and thanks to 5G, which is enabling and bringing digital twin to forefront. Okay, how 5G architecture is different from LTE is out of the scope of this question, and this is something which Barun is more relevant to a telecom network kind of a discussion, but it's out of the scope of this, Barun from Delhi. Okay, somebody, Sahu, Mumbai, career in Capgemini for 5G PhD research scholars. So not only in Capgemini, for a 5G PhD research scholar, the career will be entire globe. Best of luck. Shaju from Nagarcoil says, very nice, sir, very useful to me. Kindly you issue my certificate. I'm really sorry, that's something up to the organizers. Uh, I'll see if there are any relevant questions here. The questions relate to radiation. Does any manufacturer, for example, Tesla, use a practical application entirely? Oh, Saranya from Chennai. Saranya, there are a lot of enterprise today are using digital twin technology, and some of them are Airbus. You have Airbus, you have Boeing, and the reason why they are using is to prevent accidents. Of course, Tesla and others definitely they would be using. So I would like to take an example of digital twin in aviation industry. Imagine your aircraft is flying and its engine is continuously producing the data, and suddenly and somebody is in the engineering department is monitoring a real time engine of a flight, and suddenly notices that the engine is going to fail in next 1 hour because of some wear and tear. Imagine the potential of digital twin, how it can save lives and cost, right? But it's something which Airbus and other companies are working in detail. Currently, this is conceptual because sensors surviving in an environment of a very high temperature turbine is something which the research is going on, and if and this is something which I see a futuristic use case, but definitely it is possible through digital twin. With that, I'll take up the last question of today's session. Do you think we will be able? So this question is asked by Mukesh Kiran from Coimbatore. Do you think we will be able to achieve this in near future, as we just now have access? We have Kiran, we have already achieved this. Only thing is, uh, some of the critical use cases and real-time use cases or scenarios were difficult. There was latency in taking decisions, which will be now resolved through 5G. With that, I will end the session, and thanks for joining the session, and we'll have similar more sessions in the coming future. Thank you all.